Okay, let's finish up this problem where we started with a general form quadratic. We completed the square to end up with standard form or vertex form. We identified the vertex, and then we used that vertex to come up with the opening behavior, to talk about the minimum value, the axis of symmetry, the range, and the domain. The other two pieces of information that we're missing right now are the x and y intercepts. Let's talk about those real quick. The y-intercept is going to be very quick because we know that the y-intercept is the value of x when y equals 0, or excuse me, the value of y when x equals 0, right? So what is y in this function when we use a 0 for x? We plug 0 in for x, and we solve, or I shouldn't say solve, we evaluate, right? There are no unknown values here, so we could just plug away. We could plug this into a calculator if we wanted to, but we have fully formed adolescent brains, so we're going to do this. 2 squared is 4, 4 times 2 is 8, 8 minus 1 is 7, so we know that the y-intercept is 0, 7. That one's pretty straightforward, okay? Side note, okay, brief little interlude. I can't get my stars right on this pad. I apologize. Brief little interlude, okay? When you are given a general form quadratic, the y-intercept is going to be this number, right? Because what is the y-intercept? It's the value of y when x is 0. So this is 0, and this is 0, 0 times 8, both of those terms disappear. So in general form, the y-intercept is really easy to identify. It's whatever the floating constant is, or the non-x term in that setup, okay? So just a little aside there as a shortcut for you. Let's talk about x-intercepts. This is going to get weird, okay? So lock in. The x-intercepts are the value of x when y equals 0. So if we go about this, now we do have unknowns in this problem, right? Or an unknown, I should say. And then we have to solve for x. So we go about that by getting rid of our floating constant first, right? We add 1 to both sides of this equation. So we have 1 equals 2 times the quantity x plus 2 squared. Then we divide by 2. We want to get at that x, which is inside these parentheses, which I can't do until I get rid of this, and I can't do that until I get rid of this, right? It's all about the inverse order of operations. So now we stand at this point where we have x plus 2 quantity squared, and we said the only way to get rid of this is to take the square root. And this is what I said, this is what I meant when I said things were going to get weird. If we take the square root of both of these sides, okay, the right side's just going to be that x plus 2 quantity. Okay, I don't even need the parentheses anymore. But this is the square root of 1/2. Okay, let's jump over here. I've got a little space. The square root of 1/2, right? Radical rules dictate that taking the square root of a fraction is the same as taking the square root of the numerator and denominator separately. So I can separate the radical into the top and bottom. So we end up with here as the square root of 1 over the square root of 2. Now, keep in mind, we're taking the square root, so the positive and negative sign are in front of each of these. Okay, it's just going to get pretty cumbersome as it is, so I'm not going to keep writing that. But when we take the square root of anything in this regard, we have to include the positive and negative outputs. Okay, so now we're here, but we're not allowed to have radicals in the denominator. So we do what's called rationalizing the denominator. We're going to multiply by the square root of 2 on the top and the bottom. 1 times the square root of 2 is the square root of 2. And on the bottom, the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. So we end up with this. So the square root of 1/2 ends up being radical 2 over 2. Okay, positive and negative radical 2 over 2. So we're here, almost done. Then we've got to solve for our x by subtracting 2 from both sides, right? So we're subtracting 2 from here, and we're subtracting 2 from here. And the way that we express this when we're finally done is we typically write the non-radical term first. So it's a -2. So I'll say -2 plus or minus radical 2 over 2. And if you're looking at this and you're saying, well, that looks horrible, it does, right? This is a decimal, but any decimal that we write is really an approximation. So this is the exact answer. So this is really one number, right? It's, well, technically, I suppose it's two numbers. It's -2 plus radical 2 over 2 as one of my x-intercepts, okay, with the y-coordinate of 0. And then we also have -2 minus radical 2 over 2 comma 0, right? Really heinous looking numbers here, okay? But we have to become more comfortable with these radicals, not only for what we're going to cover later on in this course, but just because in calculus you get these crazy numbers with these crazy radicals. It's just good policy and a good habit to get into, where we're not just typing in decimals and taking approximations, okay? But just keep in mind, this is really two numbers, one where we use the plus, one where we use the minus, okay, as our intercepts.